Hello and welcome to Getting Started with Generative AI on Databricks. So if you don't know me, my name is Patrick Doe. I'm a staff technical instructor here at Databricks. I specialize in anything related to machine learning and generative AI. And my background is at a variety of different large tech companies in a variety of different roles, from software development to DevOps to machine learning, data science, and solutions architecture. Outside of work, I love going outdoors and exploring the world as much as I can and teaching that as well to others, right? So let's go and get started. What are we going to be covering and what's the big deal, right? So as for the course, it's broken up into five modules, right? Starting with this module, which is the introduction to the Databricks and Mosaic AI platform for generative AI. And then in module one, we'll be talking about an introduction into prompt engineering and the tools and products that Databricks provide to help us when it comes to that, such as notebooks, MLflow integrations and evaluations to the new prompt engineering UI. Then in module two, we'll be talking about compound AI systems that to achieve state-of-the-art production grade systems, we really have to build more than just models. They're actually systems where we have to connect a lot of different things together into a system. And the one that we're going to be focusing on in module two is RAG, or retrieval augmented generation, where we boost the performance of a model by incorporating external knowledge using something like a vector database. But there's a lot of other options out there as well. Right, then once we're done with that, we'll talk about in module three, an introduction to fine tuning and pre-training, right? At some point, we want to improve the model's performance even further, right? Where we can't really do that with a system. So it leads to data science and fine tuning a data set to go and train a model. And that's what we'll be talking about really high level, which is fine tuning and pre-training. And what do we recommend? What we found from our research team? Then finally, to wrap things up, we're going to be talking about LLM ops. So how do you go and bring these into production? How do you manage and operate them? And governance for AI applications, right, as we go forward. Okay, so let's go and jump into module zero. So module zero, introduction to Databricks and Mosaic AI for generative AI, right? So in this module, what are we going to be talking about? So understand generative AI and its opportunities and challenge, right? So what's the big deal with generative AI? What's the hype? Why is everyone talking about it? And then what are some of the challenges that companies and customers are running into as they're trying to build these and bring them out into the world? We're going to learn about the generative AI app journey on Databricks. So what does it look like to build generative AI applications? Where do you start? And what does that journey look like? And what are different stages during that journey and maturity of building your own applications? We'll then talk about an overview of the Databricks and Mosaic AI platform. What things are there to help you go and build your own generative AI applications? And then we'll jump into kind of one of the first ones, which is the Mosaic AI playground, and get to play around with a couple models. All right, so let's go ahead and get started. So the first one is the generative AI opportunity. What's the big deal? Why is everyone talking about it? And what do we see? And what are our customers doing? Right? So it's taken the world by storm, right? From MIT, IBM, right? 91% of organizations are experimenting with or investing generative AI. You're probably in this course because your organization is talking about it, or you've heard about generative AI, right? So a lot of people are interested about it. That's kind of why I was in it too, right? So, and then 75% of CEOs say companies with advanced generative AI will have a competitive advantage. I think there is a lot of value in generative AI technology, and a lot of CEOs are trying to leverage that to go and build new experiences for their customers. Finally, a lot of organizations are seeing a 40% increase in performance of employees who use generative AI. We've probably already seen this, those of us on the technical side, things like co-pilots and assistants that can help us write code much faster and more efficiently than before, right? So we're already starting to see the impacts of generative AI. So from a study from McKinsey actually expects that there's going to be significant growth in value of this above traditional AI and analytics, right? With growth of new technologies, right? With generative AI use cases, RAG being one of them, right? As well as new ones that haven't been discovered yet, right? And we expect huge increases, anywhere from 15 to 40% in the economy, right, in the next few years, and 35 to 70%, 70% in the next few decades, right? And we're already seeing this disrupt across a lot of different industries, from financial services to building advanced fraud monitoring and better claims and underwriting, right? To healthcare and sciences. We're already seeing this in the medical field with AI-powered chat assistants to go and help with your diagnosis and things. You probably heard of MedGPT and things like that, helping us out and making it easier for doctors to get diagnoses, right? From consumer media entertainment, you've probably seen generative AI artwork being created everywhere. Consumer retail, right, with helping write descriptions for products, as well as helping customer support, manufacturing, and public sector, right? We expect it to be everywhere, right? It's one of those technologies that we expect to go everywhere. And it's not just, do we expect it? We're already seeing it being implemented at already many customers. So here you can see some of the customers at Databricks that are already going out there, taking generative AI and deploying that out there, right? From Zoom to JetBlue to Edmunds, you're probably familiar with some of these companies. So to highlight a few, one of them is Replete. I don't know if you're familiar with Replete, but Replete builds a online IDE. So if you're a software developer, that's an integrated development environment, right? And one of the big things that they were trying to do is help improve the developers by providing them with AI-powered technology. You're probably familiar with things like copilots, right? And that's what they were trying to do. But one of the issues with it was that they need to have this run very fast and near real time. If you've worked with anything with autocomplete, right, it's very latency sensitive, right? So to be able to build a good experience, they need to go and train a model that would do that really well. So actually what they ended up doing is they ended up building their own model, right? It's built on Ghostwriter, right, which is a code generation model. And they trained that a 2.7 billion parameter model using free training. And they were able to do this in the span of a few weeks and do this on the Mosaic AI platform. Right, so really cool stuff. That model is actually now open source and available for you to use on Hugging Face. So pretty cool stuff there. So Replete's one of our customers, right? Really interesting use case when it comes to latency, and that really the only way to achieve lower latency is training your own models and training specific models to go and do that. Another customer is JetBlue, right? So if you're not familiar, JetBlue is an airline in the US, right? And one of the challenges that they had was they didn't really have an online feature store for that was ready to go. So it was really hard for them to kind of scale and build with their existing data warehouse, right? So that made it difficult for their data scientists to go to train and build models because of this, right? So by leveraging Databricks Lakehouse, they were actually able to speed up their data pipelines and make it easier for their data scientists to actually get access to that data and be able to train their own models. And today they're using LLMs built on their own data to build better experiences for their customers, right? As well as the Databricks platform for data collection, for real-time data streams, and everything like that. And they actually have their own digital twin for operations when it comes to everything. So they're already able to see a lot of increase in new innovation and ideas from generative AI and the Databricks platform, right? So just two customers to highlight that are already doing this, right? However, to go and get that, there is actually a lot of challenges, right? What we're seeing with a lot of customers when it comes to building and deploying production quality generative AI applications is that 90% of enterprises actually don't feel confident going into productions. You probably heard tons of stories on the news about tons of different customers running into a whole bunch of different scenarios when it comes to that, right? And a lot of that comes to the not being able to have control over their data, right? And the models, or challenges when it comes to that. Unpredictable performance and expensive costs when they're running these large scale models, right? So in order to do a lot of that, you need to, if you want to get better security, you need your own data and your own models, right? To improve that privacy, know what's going in, know what the model can go and generate, right? And you'll need built-in monitoring, right, to standardize those operations, right? Inside of Databricks, there's a lot of tooling to make it easy for you to monitor those models in production. And then finally, scaling and training, right? There's always this trade-off between really powerful large-scale models that can do everything versus smaller, fine-tuned models that are optimized for the job, right? So it's very difficult to kind of do all these things, but on the Databricks platform, we can help with all three of these. So what does that journey look like on Databricks, right? So key concerns, right, to achieve that application quality or achieve production quality, you need models that are going to be accurate, you need them to be safe, and you need them to be able to be controlled. And the key to doing all of this is your data, right? Your data is the key to unlocking accurate, safe, and secure models. And to do that on the Databricks platform, right, we want to build a platform that gives you complete control over the data and the models that you create, right? So you own the data, you own the models, you own what's being used to train them, right? And that'll help you build production quality generative AI applications, as well as lower costs for those LLMs at scale, being able to train smaller and more optimized models. So what does that journey look like, right? So we like to say the journey starts with prompt engineering, right? Which is a really easy starting point, right? And as we start with there, we can then look at systematic approaches like RAG or retrieval augmented generation. We can then optimize those models with fine tuning, and eventually at some point think about pre-training to optimize it further. And you can see here, everything on the left, right, is kind of easier to get started and simpler, whilst things on the right are more complex. However, it also means on the right, they're more compute intensive. They also require more capital and time to get started with. Right, so start with the baseline and move towards the other. And that's kind of what the goal of this course. We're going to start with prompt engineering, and we're going to go through the journey to RAG, to fine tuning and pre-training. Right. So to help you out with all this, what's on the Databricks platform, right? And what's on the Mosaic AI platform? So when you look at the core of building generative AI applications, right, you're either building an application or a system, or you're building models. Now, when it comes to doing that, it's all going to require preparing data, building models, and then serving that data and serving those AI applications. And along all these processes, we'll need to have a way to store our data and govern our AI models and everything that goes along with that. So what are other things to do, right? So we acquired Mosaic AI a couple of years ago, right? And one of the biggest things about them is really bringing everything together to provide you one place to build and train models, whether that's preparing the data from transformations to building embedding models, to developing and evaluating AI models, whether that's testing different algorithms, fine-tuning, creating complex generative AI applications and agents, to serving these models at scale, right? Everything that you kind of need. Now, what are kind of the things on the data intelligence platform, right? There's a lot of different things, right? From notebooks to DLT to workflows to help you prepare data, right? To governance tools like Unity Catalog and Lakehouse Monitoring and Delta Table to help you store your data. Right, some new things that are coming from Mosaic AI, things like MLflow to help us manage and operate our ML applications at scale, things like AutoML and fine tuning for training, as well as the AI playgrounds to make it easier to get started. And then for serving AI, the model serving service for custom models, as well as management of external models and all those things as well. Right, and we're going to talk about some of those as we go through the course. But one of the first things that we want to talk about is the Mosaic AI playground, right? And one of the cool things is when it comes to getting started, it's really hard to go and deploy your own models and run them. I think if anyone has ever done this, you kind of know what I'm talking about. And one of the first things that make this really easy is the Mosaic AI playgrounds, which make it easy for us to go and play and interact with models without having to figure out how to deploy them and do all of that. So without further ado, let's go ahead and jump into a demo. So this is the Databricks workspace, and this is how you interact with the platform. So just going over kind of the workspace really quickly, and then we'll jump into AI playgrounds. So when you're inside the workplace, this is kind of the home page. You can see at the top, we have the search bar where you can go and search for your data, your notebooks, right, and anything else inside of your workspace. On the top right, you can see which workspace you're in. You can see here we have two different workspaces. And I can also find my account information here as well. Very useful if you're a developer to go and create API credentials and things like that. Now, for the most part, whenever you want to go and work with Databricks, you'll be working with a variety of different features, and that can all be found on the left sidebar. right? We can see here kind of resources that we have in our account, from workspace files to our Unity catalog, workflows, and compute clusters. We can see our SQL features for data analysts, as well as data engineering features for creating workflows and streaming data. As for us, we're mostly interested in the machine learning capabilities, such as playgrounds, experiments, features, models, and serving. And we'll go through some of these as we go through today's course. Right, but for now, let's go and jump into the AI playgrounds, which can be found by clicking on this playgrounds button. All right, so this is the AI playgrounds, right? And you can see here a very familiar chat interface that we can use to interact with language models. Now, there are a lot of different language models to choose from. We can actually take a look by clicking on this drop down here. We can see we have Databricks Instruct and a whole bunch of other foundational models that we can play with, from Llama 3, Mixtral, right, as well as MPT, which is our older models before DBRX. You can also see here we have custom models from our organization, as well as external models as well that we can also provide in our playground. Now, for right now, we're going to be focusing on Databricks Instruct, so let's continue with that. So let's go and get started. I'm just going to go and ask it a very simple question. What is Databricks? And you can see here its response. Right now, when we're playing around with LLMs, right, what we're doing here is we're writing a prompt as our input. And depending on the prompt, we can change how the model responds. And one common way is changing the style of those prompts, or via what we call a system prompt. So I'm going to go and add a system prompt here, and we're going to say, you are a pirate. We're going to save that, and then we're going to go and regenerate this response. So now you see with this regeneration, you can see that it responded in the style of a pirate. Now, there's also other things that we might want to play around with when we're working with LLMs, right? We also might want to change some of their parameters, like the temperature, right? And some other parameters that will configure the diversity and randomness of these outputs, right? So what we can do here is we can change some of these. I'll put the temperature down to 0, the top P up, and this should give us a more consistent answer. Right, so let's go and try to give that a try. So you can see here, we got a response. And you can see here, sometimes it does and sometimes it doesn't. It's really different from model to model. Which brings up another great point, which is a lot of times when we're working with prompts, we actually want to compare different models. And that's one of the cool features inside of Playgrounds is we can actually go and compare them side by side. So let me go and clear the history here, as well as our system prompt. Right, and I'm going to go and load up another model. So we have DBRX here on the left, and we're going to go and load up Llama 3 on the right. All right, we're going to ask it the same question in this case. Tell me about Databricks. Right, and with that, we can see side by side DBRX versus Llama 3. And this is very useful, right, as we try to go and choose which models are going to work for whatever we're trying to do, as well as comparing them. And AI Playground is a very easy way to get started without having to know how to go and launch your own models and do all of that complexity. Welcome to Module 1, or Introduction to Prompt Engineering. So in this module, we're going to be talking about getting started with generative AI application development, and that starts with prompt engineering. We'll talk about kind of the tools that you'll need to use to get started, such as Databricks Notebooks and the Foundational Models API. And then we'll talk about offline evaluation with MLflow, LLM evaluation tools, such as the new evaluation UI, experiment tracking, as well as the new prompt experiments UI as well. So what is prompt engineering? It's the starting point, right? We talked about kind of in the last module, the AI Playground, and how we worked with these models is we write these inputs as prompts. Now, there are good prompts and bad prompts, and that's why there's prompt engineering, right? And prompt engineering is the idea of how do we go and write good prompts for our models. So it's crafting prompts that give us good performance, right? And the benefit of prompt engineering is it's easy to get started, right? As long as I have access to a model and some prompt interface or SDK, I can quickly get started. There's no kind of training or anything I need to go and do. And with Databricks, with the foundational models API, this is really easy to get started. So in Databricks, what do we need to do prompt engineering? So prompt engineering really is about those inputs that we want to provide to our model and how they can impact the performance. Now, there's kind of two things. We need a place to go and write prompts. So that's one thing. The other thing that we need is models, right? So in Databricks, we have the model serving, which serves models, whether those are custom models, foundational models that we support, right? Really popular models like DBRX, Llama, or external models connecting to third parties. But you can also bring in your own custom models via the Model Hub, right? So bringing in from the marketplace or Hugging Face models and things like that. And then also built into that is MLOps integration. So if you are using model serving, we also have integration to log those responses and queries as well into inference tables and lakehouse monitoring. So those are kind of the things that we need to kind of get started. And these will be used again as we go into RAG, fine tuning, and the other aspects on the platform. So let's go and get started. What are kind of the first things we need? So how do we write our first prompts with the foundational models API? There's two things we need. I talked about the first one is the Databricks notebook. So if you're not familiar, the notebook is very similar to a lot of other machine learning and data science notebooks like Jupyter notebooks, if you're familiar with those, or IPython notebooks, right? And these notebooks allow us to go and write code and text in the same place. So it supports multiple languages, Python, SQL, Scala, and R in our notebooks. It also supports collaborative development. So meaning that if you're working with a colleague, you guys can both work together in the same notebook and edit and comment and help each other out. So that's really cool. It's Jupyter compatible. So being integrated with the Databricks platform, there's certain things that we have on top of that, like MLflow integrations, but we're also compatible with all the plugins that you know from the Jupyter world, right? So it supports all of those things as well. And it's great for exploration, right? We've seen notebooks kind of grow in popularity because it's nice that we can not only write code in these, but we can also intersperse them with text and explanations and descriptions and links and images that make it easier for us to understand what was going on through the development of all of this code. It's also adaptable. We can also install our own libraries and use local modules, which I'll show you in the demos. We're going to be downloading the Databricks Generative AI SDK, which allows us to then reproduce these environments and do things like that, right? So with notebooks in Databricks, we also have integrations with MLflow experiments, what I'll show, as well as Databricks repos for version control. Very important when we're trying to go into production is keeping track of these notebooks. So many times that I was working on something and then I lost the notebook and I forgot what I did, right? So it's nice that we can version control them and track them inside of Databricks. And that helps us get to production, right? Meaning that if we can code version control these, we can then keep track of them, we can get into production. But also the cool things that integrates in the Databricks that we can actually use these notebooks as scripts to go and fire off workflows, right? And do things like that as well. So it makes it a lot easier to get into production, reproduce our work, and things like that. So really, it's built from the ground up to be enterprise ready when it comes to all the things that we need. So the notebook, kind of the first thing, that's our development environment. That's where we're going to be writing our code. The second piece that we need is where our models, right? And I talked about how we have Databricks model serving and how model serving supports custom models, foundation models, as well as external models, right? You can bring in your own models as long as there's support in MLflow, right? So MLflow today supports tons of different flavors from Hugging Face, LangChain, right? Tons of different formats out there, right? Then we have foundational models, which is what we're going to show here, which is for a lot of organizations, we want to go and run the latest and greatest models out there. So we support a variety of open source models like Llama, Mextral, and DBRX, right, as part of the API. So instead of you having to figure out how to host and manage and run these models, we've already done that for you and provided as part of an API, and that's what we'll be using, right? As well as external models. A lot of organizations are concerned with data control and security and privacy. So you can also use model serving as an AI gateway to go and connect to third parties as well. And I'll show this later in the course. Right, so really, Databricks model serving and AI gateway allow us to go and run any AI model we want on the Databricks platform, govern and control it in one place, and provide a unified API to go and access it. So with that, let's go and jump into a demo. So in the demo, we're going to show a notebook and run the foundational models API for a couple different models, right? And we'll come back in that. All right, so back into the Databricks workspace, and this time we're going to be showing a notebook and how we can interact with the platform and get things done inside of a Databricks notebook, as well as the Foundational Models API. So right here, I have a notebook open up. So if you're not familiar with notebooks, they're very similar to Jupyter notebooks or IPython notebooks. Right, and we have cells. The cells can be used to contain text or code, right? And it's really nice, so that allows us to put documentation alongside our code. So in this notebook, we're going to do a couple things, mostly focusing on just how do we go interact with the notebook, and then querying the foundational models API. And really, we're going to be looking at 3 different models. We're going to look at chat-based models, completion-based models, and embedding models. Now, whenever you work with Databricks, right, the way that Databricks works is we go and manage your compute environment for you, and you interact with it over this notebook. Right now, this notebook right now isn't connected to a compute cluster. Right, so you can see here, for us to go and get this set up, we need to go and connect it to our compute cluster. So I can go and click connect, and I actually already have a compute cluster already up and running for us, and that's going to act as our runtime environment that our notebook's going to run against, right? So now that we have that up, we are now connected. You can see the green dot. We are good to go, right? So to get started, to go and work with the foundational models, we're going to be using one of the 4 different API options, right? We actually have support for OpenAPI as well as MLflow, REST APIs, and then we have a new Databricks GenAI SDK as well. So that's what we're going to be using here. I'm going to be loading up the GenAI SDK. So we're going to run this. This is going to go and install that SDK for us. So that'll take a few seconds. Right now, do note that this SDK is brand new, so it's still changing a lot. Right. Okay, so once that's downloaded, we should be good to go. So it shouldn't take too long. Right, so now we have the SDK installed, we can go and start using the foundational models to go and do some queries, right? So foundation models. So the cool thing about Databricks is instead of having to go and figure out how to host a lot of these large language models, for example, all the ones available on Hugging Face, if you played around with them, they can be very large, that it's not just as simple as just running a model. Sometimes you need to go and set up NVIDIA drivers and all of this other stuff to make that work. So the cool thing on Databricks is we have a lot of the popular open source models already available for you to use, right? So that's what we're going to be talking about with this foundation models API here. But before that, let's go and jump over to the serving service so we can actually look at some of the models that we have available, right? So here's the serving service, and you can see here we already have a couple models already available in our environment. You can see we have DBRX Instruct, we have Llama 3, Mextral, as well as Llama 2, and embedding models as well, like BGE, and we have our older MPT models here. And the cool thing is these are all available for you to use. Now, we don't support all models, we just support most of the popular models that most people want to use. Now, if you're interested in all the other models, do let us know. All right, so with that, let's go and jump in to our notebook again and make some API calls. All right, so let's jump over to our notebook. So here we're going to be making a call to a chat completion model. Right now, there's one thing to understand when you're working with these models is they're either designed for chat completions or embeddings. Now, chat completion means that it's designed to understand this multi-turn kind of data structure, right? Where there might be multiple users that are talking to each other. So you can see here we have a system and a user, and that's going to be our input to the model, and it's going to respond to that. So I'm going to go and run that here, and we can go and get a response. So you can see here, it's making an API call out to the foundational models API, and then here's our response back, right? So you can see here our response, right? What a mixture of experts model is to DBRX Instruct. Right now, this is kind of us pulling out the message. Then you actually look at the actual API, it actually sends us back in this API request, the JSON response that very commonly known, right? And you can see here kind of the token counts as well as other things that we might want to know when we're working these models. All right, so that's a chat completion model, and most modern models are going to be using this structure when you're going to be interact with them. So what about other models? So if we go down, there's text completion models, right? So these are kind of the models that were prior to all the chat models or instruction models that we have today. So in this example here, we're going to go and make an API request to a completions API to show, for example, and in this case, we're going to be hitting the MPT30B instruct model here, right? So here you can see we have our prompt, right? Write 3 reasons why you should train an AI model on domain-specific data sets, and then we're going to get our response back. So let's go and run that. Right, so you can see here, right, it's kind of 3 reasons. You train the model. First off, it's supposed to make decisions, right? So we might want to train it, You can read the response for more information there, right? So you can also see here the JSON response as well. Very similar, right? We still get the token count, right? We still get the information, but you can see here when it comes to actual response, it's a little bit different structured here. Instead of kind of the role and things that we get with a chat completion model, here it's just the text that we get back, right? So there's that. Now, there's one more large language model to talk about, which we don't really use or think about when we're working with chat models. They're very important once we start building more complicated systems, and those are embedding models, right? So here we're going to be playing around with the embedding model. Right, so we're going to be playing especially here with BGE. All right, if you're not familiar with embedding models, they're very important when it comes to things like vector databases and similarity search systems, right? And this is actually how we store the data in this embedding space. So it's very common. We need some way to go and generate those embeddings. And some of these embedding models can be very large, but that they actually require GPUs in order to run. So in this case, we're going to be making an API call to the foundationals model service to get it embedding using BGE. All right, so here we have kind of our input, and then here is our embedding. So let's go and run that and get that response. So you can see here, very quick, very fast, and you would want that speed when you're working with it, especially if you're trying to build something like a vector database or something like that. So here we get our embeddings, right? And here's again that JSON response structure for our embeddings here. All right, so you can see here the huge vector space that we get for a lot of these. All right. Okay, so we talked about kind of the 3 common models. We talked about how we can use the foundational models API. And really all of this is just to give you a way to write code to go and start developing your generative AI applications, right? And kind of the first thing that we talked about kind of earlier is prompt engineering. And this is a way that we can then capture that prompt engineering with code, right? And be able to store that, right? So here we can see here we have kind of 2 our examples of our prompt. We have our user prompt here. You are a pirate, and our user prompt, what is Databricks, right? So you can go and run that. So basically we want it to answer in the style of a pirate. And then we're going to go and send this over to DBRX instruct, right? With the system prompt and the user prompt and get our response back. Right, so we're going to go and run that. And you can see here with our response, our matey Databricks be data analytics platform, right? You can see here it's already talking in that pirate kind of structure. Right, so with that, that gives you kind of the beginning of how we can go and use notebooks, how we can use the foundational models API to really get started with our prompt engineering. Okay, so we've shown a demo of the notebooks and how we can go and work with the foundational models using the API. Now, at some point when we're doing prompt engineering, we want to track all of these experiments and all these prompts that we're using. And one thing that we're going to use with that is integrations with MLflow. And there are kind of a couple things with MLflow that we want to work with is MLflow experiments, as well as some new features that I'm going to talk about, which is the new evaluations UI when it comes to working with LLMs. And the evaluations UI makes it really easy for us to compare outputs of multiple LLMs, right? And do this visual inspection that's kind of needed when we're working with generative AI applications. So without further ado, let's go ahead and jump into a demo and we'll take a look at that. All right, let's get started with MLflow experiments and evaluations, right? At some point in our prompt engineering process, we're going to start writing a lot of prompts, and we might have team members also writing prompts. It's very important for us to go and capture all of this work. Now, how we go and do that inside of the world of Databricks is its great integration with MLflow, and that's via MLflow experiments. And we're also going to be talking about a cool new feature, which is MLflow evaluations to help us also compare these experiments as well. Right now, to get started, I'm going to go ahead and install our packages. So we're going to go and get that to run right now. So that's going to go ahead and run. Now, while that's running in the background, let's go and open up the experiments UI and take a look at what that kind of looks like. Right, so here we have an experiment, right? And you can see this is the experiment with our notebook. So the cool thing about Databricks is every notebook, whenever you do runs on that, that's going to capture experiments with the same name as the notebook, right? And you can see here with our notebook, I've ran it 4 times earlier today, right? And you can see the 4 or the 3 runs right here with each of those experiments. We'll talk about those in a little bit, right? So you can think of kind of experiments is something I'm trying to play around with, right? So for example, I might be changing different models, or I might be doing an experiment with my prompts, right? And each of those changes would be a run in our experiment. So you can see here we have 3 different runs for our one experiment here. All right, so let's go ahead and jump back. Our library should be installed now. So you can see that good. It looks like it's all installed fine. Right now, what we're going to do here is I'm going to actually reset my experiment. For the sake of the demo, I want to clear everything just so we start off with a clean slate. Right, so what it does here, it just pulls up my experiment name using the notebook, and then it deletes all those previous runs. Right, so I'm going to go run that here. So it shouldn't take too long here. So there we go. You can see it found those 3 runs that we had earlier, and it just deleted those. Okay, so let's go and start an experiment. Now, our experiment that we're going to do here is going to be playing around with different models and comparing the outputs of those models. But you can imagine experiments can be anything else that your team comes up with, right? You could think of experimenting with your prompts. You could think about experimenting with your questions or your ground truths or whatever else you want to go and do. It's really up to your imagination. But the idea is an experiment really should be focusing on one variable that we're changing and trying to compare those variables. In our case, what we're going to be doing here is we're going to be fixing everything else, and our variable is going to be different LLM models behind the scenes, which is a very common thing to go and do. All right, so to go and do that, we're actually going to go and define a common set of inputs. Right, so for each LLM, we're going to be asking these 2 questions. What is MLflow? What is Spark? And then also one of the cool things in MLflow is MLflow evaluation for LLMs, in which it's actually going to compare the answers that the LLM generates to a ground truth, right? So here we have some ground truth from our documentation for what MLflow is and what is Spark. All right, so here we have our evaluation data, we have our inputs and our ground truths that we're going to use for comparison and evaluation. And then we also have our models, right? So this are the 3 things that we're going to really be changing. We're going to be running it against DBRX Instruct, Llama, as well as Mixtral. We're going to fix up the max tokens to 128, and we're going to set the temperatures to 0 so we can kind of get a consistent output for each of these models. All right, and then we're actually going to go and run our experiment here. So for this experiment, I have some code. What it's going to do, it's going to loop through each model, and for each model, it's going to go and do a run. And basically, you can think of a run as we're just going to generate a prediction, then we're going to evaluate that prediction. All right, so you can see here, I'm logging some of the parameters for the run. I'm going to log the model, the tokens, and the temperature. And then here, we're actually going to go run our evaluation. So new to the new MLflow is MLflow evaluation for LLMs. And that's what we're using here. We're going to go and have MLflow make a call out to our model and generate the output. Right, we're going to go give it the data set so it actually knows what to ask. And in this data set, we also have a ground truth. So that's the target, right, what we're going to compare against. And one of the cool things in MLflow Evaluate now is we can actually go and evaluate for different type of tasks, right? And in this case, the task that we're going to do is question answering, right? So really, we're going to want to compare the question and the answer that the model generates. We're going to compare that answer to the ground truth and run a couple language metrics against that. All right, we're also going to add some additional metrics here that are very important, things like token count and latency for each generation, right? It's very important to know how many tokens are being generated, as well as how long it took to generate those tokens. All right, so we're going to go ahead and run that here. Now I'm going to open up the experiment sidebar, right? If I refresh this here, you'll see that these are kind of the 3 old runs that we ran earlier today. And when we get this started, you'll see that we'll get some 3 new runs. All right, so let's go ahead and run that. So you can see here now it's kicking off our experiments. You can see here it's starting to run those experiments. You can see here it's testing the metrics and doing the evaluation, right? Computing our language metrics on those. And then now you can see it's going to continue that for the other models as well. So we just got one model that came up, and the others are coming on as well. Shouldn't take too long. Looks like we're almost there. All right, so we have all 3 runs. All right, so let's go over into our experiments UI. And when we get in there, we can see our 3 runs. So here you can see the 3 runs of our experiments, right? You can see the parameters. So you can see here are 3 runs with the 3 different models. You can see the metrics that we calculated as well as the latency. You can see pretty cool, interesting. The latency is similar for a lot of these models, right? We can go and look into one model. So I'm going to jump into this run here. We can look at this run. You can see here information about the run, the number of the experiment, right? Some important things like the data set that was used, right? The notebook that was used here as well, some of our parameters and the metrics that we calculated as well, right? So you can see here some language metrics. RE grade is really determining the language level. Is it like 7th grade, high school, middle school level, right? We have latency metrics, toxicity metrics, right, as well. All right, so pretty cool. All right, you can see here our metrics graph. You can also see artifacts, and in this case, our artifacts is our inputs and outputs from our evaluation, right? Okay, cool. So you can see our runs. Now that's great. I can log runs. I can log them inside of an experiment, but really we're doing all this to try to find which one is the best or to be able to compare them. All right, so one of the cool things with the new MLflow for LLMs is the evaluations UI. And in the evaluations UI, this allows me to go and actually compare these runs side by side. So you can see here our 3 runs that we just ran. And right now we can see the ground truth, right? Which is going to be the same for all of them, right? What we really want to see is the outputs. So here we can go and switch to outputs. We can see the outputs of each of these 3. You can go and read them on your own time and compare which one you think you like better, right? But this is very important because a lot of times when it comes to generative AI models, right, there's a little more art to the wording and what actually makes sense for us in our different use cases. So it's really common to go and do a visual inspection, actually look at the outputs. You can see here they all kind of look pretty much the same when we look at them close to each other. It looks like kind of this one's a little bit more casual, whereas these are more professional, right? All right, so you can see MLflow experiments, the new evaluations UI, and how we can use this as part of our prompt engineering workflow to capture our experiments and our changes and be able to use that to drive our development of improving those as we go along. All right, so what's next? All right, so we've finished up the demo. So at this point, we can see how we can use that experiment tracking and the integration of these notebooks onto the Databricks platform via MLflow evaluations, experiments, and things like that. Now, that's all great. A lot of us that know how to write code, that's great. Now, there is also a large group of us that are not coders, like we don't write code. And there's also another feature I want to talk about, which is the MLflow prompt engineering UI, right? One of the most important things to do when we're working with LLMs is to track our prompts, right? They're just as important as the model itself. So the new prompt engineering UI allows us to capture those prompts with no code, right? So you can see here kind of the prompt engineering UI. We can choose models, choose our inputs and evaluate those and log those as a run in our MLflow experiments, right? So I'm going to jump into a demo so we can go and see how that works as well. So let's jump into the demo here. Okay, so we talked about MLflow, we talked about the experiments and evaluations UI, and now we just talked about the new prompt experiments UI. And this is very useful, right? Instead of writing code, we talked about all these other ways that we can capture experiments. And for a lot of us, right, I might not be a software developer. I really just want to focus on more of my prompt engineering. All right, so a new thing to MLflow is the prompt experiments UI. So here you can see again the MLflow experiments, right? And these are the experiments that we ran earlier, right? And one of the new things that we can do is prompt experiments. So instead of using a notebook, we can use a UI to go and do it instead. All right, so if you go to get to that, all you have to do is click the new run button. When you click new run, you can see here we can use a notebook or we can go and use a prompt engineering. All right, so let's go and jump over to that. So with prompt engineering here, you can see we can go and do a run. We can run what a lot of times when we're working with LLMs, we're choosing a model. So we're in this case, we're going to run an example against DBRX instruct. You can see the different parameters for that. Right, we can also choose some prompt templates. Now I'm just going to use a default one in this case, which is is MLflow open source. We're going to use this template for all of them. Right, we can also define our own if we want to. So this is really an example of question answer that we were kind of showing before. We have question, we have some documentation that we might add. Right, so we're going to go and run that. We're going to click evaluate. Here's our output, and then we're going to go and click create a run. Right, so you can see here a very quick way for us to go and do new runs and compare our models. So I'm going to go do that again, except for 2 other models. So we already did DBRX instruct. Let's go and do 2 more. So let's do here Llama. 3. So let me find the Databricks Llama 3. Right, so here we can go and run Llama 3. I'm going to go run evaluate on that and create a run for Llama 3. Right, and then we're going to do one more just for fun, which is going to be Mextral. Right, so we'll run it against Mextral as well. I'm going to run evaluate on that and create run. Right, so you can see with that, very quick and easy to go and add additional runs for our models. Now, you can see here we have 6 runs. We've been comparing a lot of different models, a couple different questions, right? So let's go and refine them. We just want to look at these 3 here, right? So we're going to compare these 3, right? And here we can kind of see the comparisons of these 3, right? We can see kind of the different models. We can see the prompt templates. Right now, what I'm looking here is specifically for our prompt outputs. Don't see it here. So let me go back. Right, we're trying to look for those 3 outputs. So let's go to the evaluations preview. Right, and we can see this. And here we go. Right, so that's actually what I'm looking for. You can see is MLflow open source, and then we can see these 3 models next to each other. So I'm going to go ahead and hide these 3 other runs, and you can see here those 3. We can see DBRX instruct, Llama, as well as Mextral. So just another way that we can do experiments and play around with prompt engineering on Databricks. All right, awesome. So that's the prompt engineering UI on Databricks, right? So just wrapping up the module, we talked about prompt engineering, how it's the starting point, and how there is a lot of iteration to get good prompts versus bad prompts, and how MLflow, experiment tracking, and the tools inside Databricks make this easier for us to capture and get started, as well as a way for us to evaluate our experiments as we go on.